Next question is June 06, paper 1. From the list of the waves below, identify those that are transverse and those that are longitudinal. Write their names in the table below. So longitudinal is probably the easier one because we know we've got sound, and you can see sound in that list. And then the other one you've got there is ultrasound. The others then are all examples of waves which are found from the electromagnetic spectrum. So we just write them on the other side. They're X-rays, ultraviolent I mean. I've already the ultrasound written in there, and microwaves. And you would get a half mark each, and you would get rounded up. So once you have got 5 of those correct, you get your all 3 marks. State 2 features that electromagnetic waves have in common. And the first one there is that they all travel through a vacuum. You could also say that they travel and give their speed at 300 million meters per second, or 3 × 10⁸, in case you lose a knot. But you always have to finish that within a vacuum, because they do travel at different speeds through different mediums or materials or gases and so on. They're all transverse, so we only need 2 of these. And the other thing which is common to all waves is that they can be reflected, they can be refracted, they can be diffracted, they interfere with each other. And one which you may not know of is that they can be polarized. And that's only common to transverse waves. It can't be done with longitudinal waves. So really, if you had said even any of these ones here, any 2 of those, you would have got your 2 marks. These are the most obvious ones to write, of course. But if you do decide to write this one here, you must finish it off within a vacuum. From the list of waves above, name one which cannot travel through a vacuum. So it's either of your 2 longitudinal waves, either sound or ultrasound. I'll write U sound. So either one of those 2 will get you your 1 mark. Describe an experiment to find the position of the image of an object produced by a plane mirror. Illustrate your diagram with illustrate your answer with a diagram in the space below. Now, what you have to do this in school, we would always have shown you using a glass, piece of glass method, which is acting as a partial mirror. But I'm going to show you another example of a way that you can do this. So if you have got your mirror here, say, like that, and you take an object. Now that object is something like a pinhead, so we'll put it here. And you take your ray box. I'm going to draw a ray box in there. And I'll draw in red. Take a ray of light which passes through that, like this. Okay? And then if you draw a normal at the mirror, and mark the path of the reflected angle, or the reflected ray, you'll get something like this. Okay? And then if you take that pinhead again and you move your ray box so it's at a different position, and you draw a ray of light again, or put a ray of light which goes through your pinhead, hits a mirror, and you mark its it's reflected ray. And again, I'm just guessing here. I should be using a protractor, but I know that you'll be able to do that. Okay, so that's a ray of light coming out. And where those 2 rays meet should be the position of your image. I have a feeling my two rays may not meet too well, but we'll give it a go here and see. And you should have a good idea that, of course, where they meet should be the same position behind the mirror as the object is in front. So I think this isn't going to be too bad here, even though I've made up my angles here. And you can see there that they're going to meet roughly. Yeah, that's not too bad. There's the position of your image. I'll mark it in red. And you should see that it should be roughly the same distance behind the mirror as the object is in front. So it's not bad there. So then you have to explain how you got that. So this is your object here. All right. So to explain that, the first point I would say there is that you would use a ray box to shine a ray of light through an object. And generally you use a pin. Mark the reflected ray. Change position of ray box. Maybe I should say there, allowing a second ray of light to pass through the object. Second ray of light. I think you probably can't see this anymore. Mark new reflected ray. So we're now on 4 marks here. Extrapolate rays until they meet. Extrapolate means continue. So you're continuing behind the mirror, but they're virtual rays, so you must do them as dotted lines there. Extrapolate rays until they meet. This is image position. Now, for showing your diagram, they're saying you could get a maximum of 2 marks. And 1 mark would be showing this reflected ray here and the second here. So you've really only 4 marks to get out of your explanation here. And even like if you labelled your ray box positions 1 and 2, and then showed that this one was reflected ray 1, like that, and this one here was 2, that goes a good way to explaining, and it also will help you explain. So if you say position 1, mark reflected ray 1, mark reflected ray 2, extrapolate rays until they meet, this is image position, you should easily get your 6 marks. That kind of question is the kind of question you really should think about for 5 marks actually, as I said 6 there, because 5 marks is a lot to get for something like that, and generally that kind of question is the most poorly answered, so it is probably one you should learn.